مرحبا طلاب. أعطيتكم باللكتشر الماضية إنه على الموتور which we consider as electromechanical component or system. It's not a complete system. And we derive the transfer function of that motor, and then we derive the state variable model of that motor. And today I'm going to give you a practical application of that motor, which is I have a motor, it's an armature control. I have Vin, I have an amplifier, okay, and I have this motor. It's giving me RA, it means LA is negligible, and at the shaft of the motor we connected, or we have this valve, and there is a reservoir on the top, and this motor will open the valve whenever this level go below a certain level. And of course this tank, we'll take about tanks later. This tank has an output Q0, and it should have here a small valve, or R, not valve, R, which is like Hanafiya or trombo we call it. So here we have a Qin and we have a Q out, but we are interested in the level. We want the motor to open. Here is the theta, high theta, to open this valve. Anytime the level will go down, you know that if you want to keep Q0 fixed, the rate of flow of fluid, you should keep H fixed, okay? If you look at the data, he's giving me the K of the motor constant, that's for the torque. It's equal to 10, and of course the resistor is 10, and the amplifier gain is 50, and we have the back EMF constant KB 0.07, and he's giving me the total moment of inertia of the motor and the shaft and the valve at equal 0.006 without the unit, because sometimes they give the unit in pound and things like this, which we don't consider. And he's giving me this equation that relates theta by H. Theta, which is that one, by H. So I need an equation so that I can get the transfer function of the tank. The equation is H of t in time domain equal 1 over 50, the integral from 0 to t, 80 theta of tau minus 50 h of tau d tau. You know they use tau if you have a limit that is a specific limit, not infinity. So he need to find the transfer function h of s to Vn of s. So if you look at the figure, you will find that we have three components. This is the amplifier, and then the motor, and then the tank with whatever come with it, okay? So first of all, we can put the block diagram of the system, and you remember that if we have a block diagram like cascaded transfer function, we can find the transfer function, the total. So what did I do? This is the amplifier, that's the input Vn of s in Laplace, of course. This is the amplifier transfer function Ka equal 50, it's just a gain. And this is the motor, which we remember, Ks over S plus alpha, or there I put here Tm, it's the same, Tm here. If I put Tm here, it's 1 over alpha. And what I get, it's theta S, that one. Then I have the tank. I put the tank transfer function, a general fall, A over S plus B, okay? And the output Hs. So I have three components, okay? This is known, and this we have to find from the data he's given to me, and this I'll have to get from the equation which he's given me. Now let's work that way. Let's find h over theta of s. So I have h of t, so in 1 over 50, the integral from 0 to t, 50 theta of tau minus 50 h of tau d tau. So if I take Laplace transform of both sides, that will make life easier for you. Okay, we'll take the Laplace, it will be 1 over 50s, 80 theta of s minus 50 h of s. Take the 0 out of all of those. So I'll have, take this s to the other side, multiply, both sides by s. So I'll have s, h of s, and I transfer H after I take the 5 out of here and here, plus H of S equal 8 over 5 theta of S, and it's equal 1.6 theta of S. So I have from here S plus 1, okay, S plus 1, H of S equal 1.6 theta of S, then H of S over theta of S equal 1.6 over S plus 1. إذن أقدر هاي أعبيها هنا in the block diagram as 1.6 over S plus 1. This is the transfer function هاي of the tank with theta. You see, I'll go back here. Theta is the input and H is the output. And sometimes if they need a Q naught of the output, you can find a relationship, it's okay. But now we want H. So the input is theta, the output is H, okay? Which is the position of the bulb. So you want the position of the bulb to open every time that Q naught is, the level is gone down by an amount. Now, for the motor, okay, for the motor, we have a general transfer function K على S في S plus theta alpha, and this form is written in a sheet. I remember I've given, I used it in control book, so I can give it to you so that you can use it. Alpha equal 1 over Tm, and I give it in the definition before so that you don't get confused. Alpha equal 1 over J dm plus Kt Kb over Ra. Dm is not given, so it's consider it as 0. So equal 1 over 0.006, and Kt is given to me by 10, Kb 0.07, Ra equal to 10. So alpha equal 11.66 if I calculate it. K equal Ra over Jm Kb and equal 10 over 0.006, J, which is J motor or J, times 0.07. So I'll get K equal 1.66.667 if I go up there. So then theta S, which is the output of the motor, the motion of the motor, over VA, which is the output of the amplifier, the output from the amplifier, not VN, VA after the amplifier. It will be 166.667 by S, VS plus 11. That's alpha, and that's K. We find alpha 11.67 and K equal 166.667. So I'll find all the transfer function. Now if we go back to the block diagram which we drawn in the beginning, so we have the amplifier is here 50, here is the motor, and here is the tank. طبعا the tank وملحقاته ممكن تقول بس over the tank. If you remember that if I have this G1, G2, G3, so the transfer function H to Vn of S equal G1, G2, G3. So I multiply 50 times this one and times this one. This will be the overall transfer function. Of course, I derived for you the state variable equation for the motor in a different way, but here if you have this transfer function, you can derive the state variable. Find state variable model from this transfer function. Of course, this is a model of a complete system that contains 3 parts. It's different from the one which I find for you. That what was for just a motor. Here is a complete system. So if you find a transfer function here, you can do the state variable. The best way is the one which I taught you, that you make a block diagram and you find the state variable after you find a transfer function. So that will be the easiest way. Now I'll continue so that I'll finish. This is short. I'll make it short, this chapter, because it's electrical system and some of them are a bit simple for you, for your level, because you've taken a lot of electrical circuits. And I know you've taken amplifier as well, but I'll give you a bit of amplifiers. So it's section 6.6. It's a mathematical modeling of operational amplifier. And you all know that operational amplifiers come into a wide range of devices and electronic devices and in control and filtering and all sorts, in instrumentation and measurement, in sensors to amplify the signals. Actually, it's no matter how much you say about amplifier, it's considered little because it's used everywhere. So, you know, remember this typical amplifier that it has at the output R2 and the input R1. This is E in, this is E on. And remember that the input impedance or the gain of this amplifier is very, very high, so that the current here, it's almost zero, so that I1 here equal I2 here, okay? Based on this, we can that V out over R2 equal E in over R1, which is, that's the current, and that's the current for this one, okay? We have إشارة اللي هي negative, so that I go directly, I say E in over R1 equal minus E out over R2. So in Laplace, I go E in of S over R1 equal E out of S over R2, okay? This is, will give me again amplifier. If you remember the PID, this will give me a proportional controller because it's just a gain and you can choose R2 greater than R1. You will get amplification for the signal which is coming in. And here we put E, I can consider it like error, let's say. And this is your controller. So E will be amplified because the error signals sometimes become very, very small. So you have to amplify it. So this is the transfer function of this amplifier. Let's put it that way. This is the transfer function of an, we call it inverting amplifier. This is with gain. If you want R2 equal R1, then it's just for inverting. But if R2 greater than R1, then this is a gain, okay? From this, I can say that the general form of this such amplifier will be something like this. I mean, Z out over Z in, of course, of S. This is E in of S. This is Laplace transform. In Laplace transform, I'm written here, okay? So we know that E out over E in, we apply the rule which we done in the page before, that it's equal minus Z2 over Z1, and it's equal, so whatever is Z2, and maybe later when we have PI, PD, PID controller, I'll construct and construct amplifier circuit for you so that we can do those controllers. They are used a lot for electrical controllers. So this will be the general form of inverting amplifier with gain. If we take an example, let's say مباشر, we have this is Z2 and this one is Z1. He wants E out over E in. Z1 equal R1, Z2, these are in parallel, so it's R2 times 1 over C of S على R2 plus 1 over CS and equal R2 over R2 CS plus 1. The transfer function will be, as we said, Z2 over Z1. It will be R2 over R1 times R2 CS plus 1. And this is the transfer function of the, and these are active filters, controllers, and I'll come later across this when we get to this part of the material. Okay. Now let's consider this example. Sometimes this is a filter as well, non-active filters, as we say. This is a problem. He has a problem A, like A, and the problem, if he say problem A, it's an example if you notice from the book. If a problem is B, then it's a problem, needs solution. This is an example in the middle of the chamber, and this book gives very good examples. So if you go through the examples, it will be a good experience and practice for you for the chapters. And if you need any of the problem, maybe I'll give you some of the problems from the end of chapters. Now, I'll look into the transfer function of this, then I'll divert from it, go into the state variable model of the system. So this is the system given to me. It's En, the output is here, and it has R1, C1, R2, C2. First, put in Laplace, so this is Laplace transform. So I put it, this is R1, this is 1 over SC1, this is R2, this is 1 over SC2, and this is E out of S, this is En of S. Okay, so first of all, you put in Laplace. That's the first step you have to do. So Z out equal R2 plus 1 over C2S. Zn equal those two in parallel, so it equal R1 times 1 over C1S over R1 plus 1 over C1S. So Zn equal R1, put this, take it down, the C1S, it equal R1 C1S plus 1. So then E out over En, remember, أنا حطيت القانون. E out over En in such cases, okay, equal E out, Z out, I mean, over Zn plus Z out. Zn plus Z out is the total impedance. This is like a law. If you remember, it will be useful to you. So if you don't remember, then you can go by finding the current. If you put this as Z1, this is as Z2, for the total current come here is I. For E out equal التيار اللي هو En over the total impedance times Z2, it will, you'll find E out. So it's the same thing. It's come from there. So then E out over En equals Z out over Zn plus Z out, right? Then we substitute. It's a bit lengthy, but because it doesn't have numbers, it's in terms of R1, R2, C1, C2, that's why it makes it long. So we put it as you have two methods to go into. I want to find two state variable soon. Derive, I put the what I need here. Derive the state variable equation and output equation. The output is E out, which is across the R2 plus C2. Now, you can go into time domain, put it into differential equation, and you remember from differential equation, you start to assume let x1 equal a1 dot, a1, x2 equal a1 dot, and things like this, which is the usual method that we do. What I want you to learn is from the transfer function, because you need a transfer function, go into the block diagram, which I taught you last time in the state variable in chapter 4, chapter 5 actually, not 4. And from that method, it will be easier for you, because if you have a transfer function like that one, no need to go into differential, then assume the state variable. Do you know what I mean? So you have two methods. This is one method. هاي هنقول هاي method 1. No need. Question mark. I put the question mark here so that you remember what I'm talking about. Question mark. The book is going into that method. If you like, you can look into it, okay? But I'm going to make you like what I did in last chapter, so that you can grasp a method which is easier. Because that method, it's more difficult because I have, look here carefully, I have E1, which is the input, double dot, plus E1 dot, plus En. If I had the derivative of the input and second derivative of the input, I told you the method will be more difficult. The best way is the block diagram. Now, if I simplify it, let's say, because if we have numbers for these R1, C1, R2, C2, then it will be easier. But let's put it as constant A, B, C, D. Let's say we find that Y of S over U of S, it will be something like that. B naught S square plus B1S plus B2 over S square plus A1S plus A2, and A and B's and R are like that. A1 equal the coefficient of the S square. So the coefficient of the S square, you must make it equal to 1. So we divided over the coefficient of the S square in the previous equation, and we get this for A1, that's A1, that's A2, A1 1 over R1 C1 plus 1 over R2 C2 plus 1 over R2 C2. So let me check that one. And A2 equal 1 over R1 C1 R2 C2, and B0 equal to 1. B1 equal 1 over R1 C1 plus 1 over R2 C2, and B2 equal 1 over R1 C1 R2 C2. Now, now notice this. We have numerator. I wrote it for here of same degree. So I have S square here and S square here. If I have something like that, maybe you remember from the Laplace, which we started with at the beginning of the term, that if we have something like that, we have to divide this over this. Okay, so after we divide, I hope I'm correct by dividing. So we get B0 زائدا B1 minus B0 A في S plus B2 minus A2 B0 over the numerator is the same. So that's what's left, and that's the نتيجة الdivision. So it means that Y equal U, B0 times U plus this times U, right? Now let's say that this equal B1 minus B0 A1 equal B dash, and this equal B2, this is B1 dash, this is B2 dash, and I don't have B0, it's here like that. So okay, so what we have, so I have B1 dash equal B0 ناقصا B0 times A equal B0 is equal to 1, I B0 equal to 1, so I just simplify it. So it's B1 minus A1 and equal something like that. And B2 dash, which is that one, is equal B2 minus A2 B0, which is equal B2 minus A2, and B2 and A2 are equal, so this will be 0. So now we construct the block diagram. I hope I'll continue in the next video, as I don't want the video to be too long. So I'll continue from here in the next one. Thank you.